All right, everybody, let's get started. This is lecture 23. I've decided to go ahead and pre-record this lecture. As I mentioned in the Teams channel, with the storms and whatnot, there was a pretty major a bit of damage outside my neighborhood and whatnot. I posted some pictures to the Teams channel, but this is one that's a little bit more close up. This is the sign and whatnot that collapsed over the road, and this is sort of a more in-depth view. It's just a gnarled mess and whatnot, and unfortunately that's the only entry point in and out of my neighborhood right now, so I am sort of stuck here at home right now. The work crews, I went out and spoke to the work crews. They said that they'd probably be able to get it cleared up, but I know we're also supposed to get hit with some more bad weather a little bit later today, so I thought it would just be prudent to go ahead and just assume that I might not be able to get out. So I want to go ahead and pre-record this lecture. A couple things. I know on Monday I said I was still updating attendance. My goal is to have attendance updated by the time this video goes live. And because of the fact that I'm pre-recording the lecture, I'm going to go ahead and count everybody in class present for today. Okay, so I'm just going to count everybody present. So that way you'll get a bump there. And again, there's no homework assignment this week. This exercise is going to be incorporated into the week 14 assembly assignment. So with that, I want to go ahead and just get right into things. Let me pull up the lecture notes here for today's exercise. Let me put that on the other screen. There we go. So today what we're going to do is continue our discussion in Inventor on part creation, and we're going to be doing part revolutions. And then I want to cover some additional topics in creating drawings, namely section views and whatnot. So just to get everybody back into speed of things, we're going to be focusing on this assembly. We did one part of it on Monday, and we're going to do another part today. We're going to do the wheel today. The focus of today is to revolve that wheel using the revolve command. We're also going to be generating some section views for the wheel. Okay, this is a view of what the drawing should look like when it's all said and done. And so the reason that we're using the revolve command, so just sort of to give you kind of an idea of what we're looking at. So we're going to create a sketch, and then we're going to sort of spin that sketch about an axis. And by taking that sketch and spinning it, we're going to get this wheel. So the revolve command is really good for axis symmetric commands, or axis symmetric shapes. So any shape that is symmetric about a given axis or is spun around. So a good example of where the revolve command comes into play is things like a wheel. If you're doing like a pipe elbow, you can maybe revolve only like 90 degrees or something like that. But wheels and gears and things like that are very good examples of situations where the revolve command would be very nice. Okay, so I want to kind of show you how this works. One thing I did want to mention, so I have posted the tutorial for this lecture. It's on Blackboard. Again, I normally have a hard copy in class. Obviously we're not if we're not going to have class tomorrow. What I'll probably do is print out a hard copy so that everybody has one. And I'll probably bring it to class on Monday and distribute those along with the tutorial that I distribute for Monday's lecture when we start doing stress analysis. So that way you'll have a hard copy of this. Okay, so essentially what we're going to do in Inventor is we're going to reproduce this sketch and then we're going to revolve it. So essentially what we're looking at is this, if I go back to the PowerPoint, we're essentially drawing this shape right here, but we're sort of drawing it this way. And we're also going to draw a line right here. And then if we spin that shape about that line, we'll get this wheel. So that's essentially how we're going to generate the part. Okay, so let's go ahead and go to Inventor. So here's Inventor. I'm going to create a new part. Now remember, we're in metric land, so I'm going to go to the metric box. I'm going to create a standard metric part. We're going to create this. Once it does its thing, we're going to save this part. So let me scooch this over here. We don't need all that space. I'm going to hit File, Save As. We'll put this on the desktop and we'll call it Wheel. So again, I always think it's a good idea in Inventor and everything that you're looking at, make sure that you save often. Save often throughout your work. Okay, so we're going to create a 2D sketch. I'm going to put this 2D sketch over here so I can sort of review it as we're creating this sketch. So we're going to start a 2D sketch. So I start a 2D sketch. I'm going to place it on the XY plane. Again, this is something I think, this part should be pretty familiar at this point. There's nothing really different here. And I'm going to create this sketch. And again, the way Inventor works, you can sort of create it roughly and then dimension it later. So I'm going to do the same thing. I'm going to create a single line right here. Okay. And then I'm going to create another series of lines. I'm going to try and draw the shape as closely as possible. Let's see. Looks about like that. That. Now this is not at a right angle. This is sort of up about like that. So I'll do this. That lines up. That lines up. That. Okay. So this is about what we've got going on. And the big thing that's important is that not only do we have this sort of like letter, this sort of odd looking letter H, but we also have a line right there. We need both the H and the line. Okay. So just something to keep in mind. Okay. So, okay. Let's start constraining this. Okay. So again, I've got the dimensions of this shape right here. So I'm basically just going to follow this. So let's do the basic ones. Let's start off with this one. We know that's 50. And usually the way Inventor works is whenever you place that first dimension, it sort of scales everything up because that's sort of what Inventor says is, okay, that's kind of what you need. Okay, so we're going to, let's see, this one's also 50. That length doesn't really matter that much, but let's go ahead and just put that there. This is 6. Okay, now I also have a dimension here of 12. That dimension is kind of important because for the wheel, the central hole of the wheel, if I go back to the PowerPoint, this hole has this center hole at the very middle of the wheel. The inner part has a diameter of 24 millimeters. So what I'm doing is I'm setting this dimension here to be 12 so that when I spin it, the hole is 24 millimeters in diameter. Okay, so let's see what else. Okay, this line right here is 20. This dimension from here, so here's what I'll do. Instead of dimensioning a point, I'll dimension from a line. Oh, I'll dimension from a line to a line and say that that's 10. Okay, so the idea is now I actually don't need to dimension this one because if this is 50, that's 20, that's 10. This is already going to be 20. In fact, Inventor says you don't need to place that dimension because it's already dimensioned, so you can leave that one alone. You also don't need to place this one, this dimension right here, because Inventor already knows those are right lines, right angles. Okay, what's left? Let's see. We've got this dimension. Oh, sorry, I got to activate the dimension command. This dimension is 38. Let's see. This dimension right here is 3. This dimension also is 3. Oh, I said 3, not 30. So I'm just hit the Control Z to undo. Let's see. I have a dimension here. Oh, let's redo that. I put it's from here to here. That dimension is 5, and same thing here. Dimension here, 5. Okay, shape's coming into focus a little bit. Let's see, what are we missing? Let's see. I think this dimension right here is 14. All right. I think this dimension here is 14, but I don't need that one. 38. Think I got everything. Now, some of you might be thinking, might be going on, well, wait a minute. If you look here at the bottom, I'll move my camera here on the screen. So if you look at the bottom, it says 2 dimensions needed. Basically, Inventor has a way of figuring out how many dimensions are needed to fully constrain the sketch. you can go into this auto dimension button right here at the very top. Let me activate Inventor. So this dimension here, automatic dimension and constraints, I would not use this very often but it is kind of a nice guide. So like, for example, if I select everything and hit apply, it does 2 dimensions. It places a dimension here and a dimension here. And it does give you a little bit of info for what dimensions are missing. So for example, this dimension's missing and this dimension's missing. So what you can do is say, okay, let's actually place the ones I want. Okay, so I know that I want a dimension from here to here. I want that dimension to be 50. Okay, so that helps you provide more clarity in your sketch. What else is missing? Maybe we'll do that automatic dimension command one more time. Okay, so we're missing this one right here. So we can apply it if we want. I don't really think it's all that necessary, but we can. So if I delete this, I can apply a dimension from here to here of 32. I don't really think it's necessary. Didn't really change anything. But that automatic dimension button can help you identify if there's any dimensions that are missing. But I wouldn't accept them. I would sort of hit undo and then sort of apply the ones that you want. But if you look, if I move my camera now the sketch is fully constrained. So now there's no way to modify this sketch anymore. Okay, so I'm going to hit finish. And let me bring this into view. Okay, so now, again, I have a sketch and I have a line. Okay, that's what I've got, a sketch and a line. Or I'll move that out of the way so you can kind of see. So now I want to revolve that sketch. Okay, so instead of using the extrude command, we're going to use the revolve command. So here's the revolve command. So what Inventor did is it said, okay, here's the sketch. Are there any closed regions in that sketch? Yes, there's this H, looks like a letter H. It's kind of that. But we have to select an axis. If you look here in the view, we have profile, we have select axis. And the select axis has this red arrow. So if you click this and you say select an axis, bam. Now it knows what's going on. Now, just to sort of illustrate what's going on here, I'm going to change the angle to like, I don't know, 120. And if I rotate a little bit, what it's doing is it's rotating that 120 degrees. Okay, so you can kind of see that's a 120 degree angle. So it's starting that way and it's rotating. The way that it does that is it rotates using the right hand rule. So the idea is that your thumb faces in the direction of the axis, and then your right hand, the fingers curl around the direction that it's rotating. That really doesn't matter for us because we're just going to be doing 360 degrees. You can click this button here next to the angle where it says full, and it does a full rotation. We hit OK, and actually our part's done. There's the wheel. Okay, so we have a fully defined wheel. I'm going to save this part, and wheel's done. Okay, wheel is finished. Okay, so now I want to create a drawing for this wheel. So I'm going to go to File, New Drawing. I'm just going to use a template. There we've got our drawing. Okay, I'm going to File, Save As, and we'll call this Wheel, or maybe call it Wheel Drawing. What did I put it here in the handout? I think I called it Wheel Drawing. Let's hit File, Save As, call it Wheel Drawing. Okay, doesn't really matter, but okay. So we have wheel drawing. Now what I'm going to do is, before we get into drafting land, into placing views, I'm going to do a lot of the same stuff I did before. So I'm going to go into File, iProperties. I'm going to change a lot of stuff. So let me move that over here. So here's my iProperties. I'll make that a little smaller. And I'm going to zoom here. Let me hit close. Let me zoom here into the title block so you can see. So let's go to File, iProperties. So again, this is the same way I did this before. I just go to File, iProperties, and then I'm going to modify these properties such that the title block automatically gets modified. So we'll go to Summary, and where it says Title, I think we're going to call this Wheel. We'll just call it Wheel. And let's just go ahead and hit Apply. And now you can see that the wheel pops up. Now again, we use all caps, so we'll call the author GKM. Actually, let's do this. Let's call the author ABC, because let's say you as the student, you're the one drawing it. ABC, the company. Marshall University CECS. There we go. So I'm just hitting apply, and you can see that it's adding here. Project. I'm going to create, instead where it says drawing number, I'm going to say, like I did last time. So that's just, putting that there. And then the only other thing I'm going to do is I'm going to go to status, just like last time. We'll say that you as the student are drafting it, but I am checking them and approving them. And there we go. So now we have our title block filled. The other thing that we're going to do is we're going to change the paper size like we did last time. And we're going to change the title block size. So remember, over here on the left, we have the model tree. I'm going to right-click the sheet and change that to sheet B. So again, what I did is I right-click just sheet 1 directly, right-click and hit edit sheet. And then that title block, I don't like it. It's kind of big. So I go into title blocks. And if you look over here on the left, you can see that for our sheet, it's applying the large one. I want to apply the ANSI-A. So I'll just double click, hit yes, and now I got a little bit of a small title block. So now I've got room to do some drawing. Okay, so I need to place some views. So what I'm going to do, let me pull up my slides here. This is essentially what I'm trying to recreate. So I've got essentially an isometric view, a top view, but then I got this section view. The section view is new. Okay, this is sort of the part I want to focus on. But let's get the other stuff done first. Let's do a base view. So hold on, let me, I don't want to go too fast. So I go here up top where it says place views. I'm placing a base view. I'm going to go to, here on the screen, and I'm going to change this to an isometric view. And then as long as this is 1-to-1, I hit OK. There's my wheel. Okay, so we'll move this somewhere about like that, kind of like that. I think that's good. And, the next thing I'm going to do is place a top view. So here's my top view. Okay. Whoops, sorry. Here's my top view. So I'm going to place a top view right here. And then I want to place this and then talk about why we're doing the section view for this drawing. Okay. So here's the top view. So we're going to go right here. Remember, I can use this rotation cube. Here's the rotation cube. I can use the rotation cube to sort of like do whatever side I want. You're not really getting much of a difference on the front and the left and the top because it's a wheel, right? It looks the same either way. But the top view, now that looks different. So we'll hit OK. Okay. Now, here's the thing about this wheel. The inside, it's sort of an odd cross-section, right? I mean, we took the letter H and we spun it, okay? So in order to really like easily describe what the wheel looks like, I think the easiest way to do that would be to look inside it. It's almost like if I took a samurai sword or a lightsaber and I cut the wheel in half. I kind of want to see what the wheel looks like when I cut it in half, okay? And that's what a section view is. A section view is looking at the inside of the wheel, okay? So the way that we do that, we notice we have a couple of different views up here, and we haven't really talked about this. So base views, projected views, auxiliary views, these are just really sort of different ways of looking at this, and we can handle that with just using the base command. But I want to look at the section command. Okay, so the way the section command works, let me hit escape. So here I'm hitting escape a few times. Remember, that's our secret weapon, just hitting escape over and over. So here's the drawing. I'm going to hit the section view. Okay, now I'm going to click the. Whoop. Actually, hold on. Let me do that again because I accidentally hit 2 buttons on my mouse. Let's hit escape. Let's do the section command. And so the section command, the way that it works is the section command has to reference a view that you've already placed. So I'm going to reference this view. Okay, so I click it and the cursor changes a little bit. Let me do that again. So we'll hit section view and see how the cursor goes from this. And when I click it, now it's a crosshair. Okay, so what I'm going to do is draw a line. Okay, now I'm on purpose going to draw the line in an asymmetric fashion. Like I'm not going to draw it a line. I'm going to draw it off. And I'm doing it on purpose because we're going to constrain it later. Okay, so let's draw a line. Let's click and draw a line about like that. Okay, now you can keep on drawing lines if you want, but I don't need to draw any line. I just need to draw one. So I'm going to right click and then I'm going to hit continue. Okay, now what I can do is place this section view. Okay, now what I'm going to do is I'm going to go ahead and place it just right here and hit OK and hit OK. Now let me kind of explain what's going on. Okay, so what I did when I drew that line is I drew the line and I said, this is what the section looks like if I samurai sword or lightsaber through that line. Okay, now I drew it kind of off because I want to constrain it later. Now, what do I mean by that? I want a section view that is right through the middle. I want it through the middle all the way through. Okay, so I drew this sort of arbitrary line. Let's constrain it now. Okay, let's constrain it to be what I want to be. Okay, so this is going to be very similar to how we did holes. Remember how we placed the holes wherever we wanted and then we constrained it later? We're going to do it the same way. So if you look over here in the left on the model tree, so let's look at sheet 1. We have the board. So what objects are in sheet 1? We have the border, we have the title block, we have these two views, right? So what do we have? Default, border, ANSI, view 1. View 1 is this ISO view. View 2 is this wheel. And if we look inside the view wheel, we have the section. So the section is part of this second view. So if I drop that down, I have a sketch. Okay, let's double click this sketch. So here's a sketch. So I have a sketch, and what do I have? What are my objects for this sketch? The only object is this blue line. I need to create some constraints for this line. Okay, so here's how I'm going to do this. Okay, so I'm going to use a total of 3 constraints. Okay, the first constraint I'm going to use is a vertical constraint. Okay, so if we go up here up top, remember this is the dimension bar. It's the same, like we've looked at this constraint bar before. There's a lot of constraints up here that we can use. Now we've used the dimension constraint, we've used the coincident constraint. A lot of these other ones we haven't used directly. Indirectly, Inventor has been applying them for us. Like if we draw a box, Inventor will automatically say that this line is vertical or horizontal. I want to apply a vertical constraint. So watch this. I'm going to click the vertical constraint button. That's this button right here. I'm going to click the vertical constraint and I'm going to apply a vertical constraint to this line. And then what it does is it forces the line to be vertical. Okay, it's the same length, but it's forcing it to be vertical. Okay, so that's the first constraint I'm going to apply. The second constraint I'm going to apply is a dimension constraint. I'm going to make this line a certain length. Oh, what's going on? What's going on here? Why is this 5.371? It's because we didn't change the dimension or the units of the file. It's something that's kind of easy to forget. It's okay. So like if I place a dimension and I make it 120, it's going to think it's 120 inches, and that's way too much. Okay, so what I'm going to do is I'm going to finish my sketch. I'm going to finish this. Oh, look what happened. The section changed. It's not enough, but it changed a little bit. Remember, I can go into tools, I can go into document settings, I can change those units to metric, and now when I start applying constraints, the constraints will be of the appropriate units. So let's go back to the sketch over here on the left, double click to edit. Now let's do that dimension constraint again. Do that. Those units are looking a little bit more, they look like they make a little bit more sense. Okay, I'm going to place this line, I'm going to place a dimension constraint so that the line is 120 millimeters. Okay, so 120 millimeters exactly. I'm doing 120 because the wheel itself is 100 millimeters in diameter when it's all said and done. So I want the section line to be a little bit bigger than that. I want it to fully go through the part from top to bottom. Okay, and I just like the fact that like when it's done, the section view will be a little bit outside the wheel. I think it aesthetically looks a little bit better. Okay, the only other thing left to do is to place the place the line where I want it. And I want the line to go right smack dab through the middle of the wheel. Okay, so the way I'm going to do that is I'm going to remember that point creation where you can create a point in a sketch up here in the sketch command. I'm going to create a point in the middle of the wheel. Okay, then I'm going to create a coincident point constraint. And what I'm going to do is I'm going to constrain it such that the midpoint of this line lies here. Okay, so now it is a vertical line going right smack dab through the middle, and it's 120 millimeters, so it's actually going outside the wheel a little bit. Now watch what happens when I hit finish. Let's hit finish. Boom. Now it looks pretty good. Now it's going right through the wheel, and you can really kind of see the interior detail of the wheel pretty well because it's kind of, you know, you can see the shape. You can also see this sort of like H pattern, as it were. It's just the H pattern is it's sort of an I shape because it's rotated a little bit. But I think that looks better here on the sheet. Okay, so a couple things I'm going to do. I'm going to drag this label down a little bit just so it's not overlapping. And then the only thing left to do is dimension this thing. We need to dimension it. We need to maybe get it arranged a little bit, make sure we have everything where we want it, and hit print. So I'm going to follow the template that I gave you all in the slides and in the handout, and I'm just going to start placing my dimensions. Again, a lot of these are going to be pretty straightforward. So, and I sort of purposefully did them in a couple different locations just to make sure that you're comfortable with the different dimensions. So I put a dimension here of 100. Hit OK. I put a dimension on this outer ring. I think I put it there. That's probably fine. 36. Let's see. I put a dimension right here. Let's put that about right there. 50. I have a dimension right here of 38. I'm actually placing less dimensions here on the drawing than I did than I needed for the sketch. Because this is an axis symmetric object. It's a wheel, so it's going to be symmetric about this vertical center line and whatnot. So put a dimension there. Now for these dimensions right here, I put make sure don't select the midpoint. Select the actual line itself. So I put a dimension there. Then I put a dimension from this point to this point right here of 5. We'll hit escape a few times, and then again you can modify the position of those after you've placed them. So like this one I'm going to do about like that. I'm going to put this 5. I think I put this 5 up here. I can put the 3 down. I think I move that in a little bit. Put that about like this. I think I like that. I think that's pretty good. Okay. Let's see, did I get them all? Yeah, I think I got them all. I'm going to drag this over a little bit. And again, because of the way that we created the section view, it's already attached to the top view of the wheel. So I can't like move the section view without moving move the top view without moving the section view as well. It's already linked. I think I'll move this out maybe a little bit. Yeah, I kind of like that. I think that's good. I'll move that down a little bit. Okay, I kind of like that. I think that's good. So the only thing left to do is I'm going to print. Again, we go to File, Plot. Or oh, wait, no, that's not the only thing I'm going to do. I'm going to save my file. Remember, we save, save, save. Whenever you close, make sure you save. So we're going to hit File, Print. And we're going to, let's see, what printer do we want to use? We'll do the Microsoft Print to PDF. We'll hit Properties. We'll do our Advanced tab, and we'll do remember the tabloid sheet of paper, either 11 by 17 tabloid, size B, as long as it corresponds to the sheet that we already specified, because we specified an ANSI earlier. We hit OK. Let's preview it to make sure it looks the way we want. Looks good to me. We'll hit Print up here, hit OK. Put this on the desktop. Take my caps lock off. I don't need a caps lock for this. wheel drawing. And there we go. Let's go to the desktop. What do we have here on the desktop? Let's see. So let's sort of take stock of all these files when it's all said and done. Here's the drawing. That's the drawing we just created. Looks pretty good to me. I think that's pretty straightforward. Just so you're aware, so let's look at all the files that we generated from this. So I'm going to save all this. I'm going to close Inventor. So let's close this, save this file, close this. Okay. So a couple things. So here's everything that we actually created for this. We have the Inventor part itself. Now we have two drawings. That's because like I saved the first one as wheel, and then I saved the second one as wheel drawing. So this one actually wasn't a drawing for the files that we were looking at. So essentially what we have is we have the Inventor part, we have the drawing, and then we have the PDF that we just printed. There's also a folder called old versions, and if you open that, what'll happen is old versions will contain different iterations of the files that you created, and that's a function of how many times that you hit the save button. So if you're saving regularly, this file should be populated with a lot of stuff. So you definitely want to keep this together. So my advice to you is to put all this in the same folder as your base plate, because ultimately when we do the assembly, we're going to put the base plate, the wheel, the bracket, the axle all in one folder, and put an assembly file in that folder and put it all together. Okay. So with that, that's all I've got for this recorded lecture. So we're actually ending a little early. One thing I'll mention, so I gave you information on 4 parts: the base plate, the wheel. Here, let's pull up the assembly drawings. Let's go ahead and pull these up. Okay, so we have all this. Oh, didn't mean to minimize that. I meant to minimize this. Okay, so here is our assembly. We have 4 parts, okay? So we have the base plate, we have the wheel, we have the angle bracket, and we have the axle, okay? Now, I'm not going to collect anything for a homework assignment this week, but I do think it's a good idea that you go ahead and try and make an attempt to construct the bracket and the axle, okay? Now, the only thing on the axle that we haven't discussed is the chamfer. I'll have some details on that, but the chamfer is really easy. It's just instead of a fillet, you do a chamfer with the size 2. It's pretty straightforward. But the bracket, you should have all the skills necessary to build this bracket on your, like right now. I am not collecting this for homework this week, but I do think it's a good idea that you go ahead and start working on the bracket, okay? The bracket is much more difficult than the axle. The axle is really simple. And if you've got the bracket, the axle, this and this done, then you can you can be ready to start assembling. During week 14 on Monday, we're going to go through the process of assembling this thing in class. And then I'll have a recorded lecture on Wednesday to go through some fine details on the drawing for the assembly and so on and so forth. Because I'm probably going to have, instead of having you reproduce like 6 sheets like I have here, I'm probably going to have you reproduce just one really big sheet so that it's a little easier for you to manage them. Then you submit that PDF to Blackboard, and that'll be the end of Engineering 102. So again, I think it's a good idea to go ahead and start building this part in Inventor and saving that file. And with that, that's all I've got, everybody. Stay safe, and I will see you next week. Oh, one other thing. I will probably still go ahead and have my help session on Friday in case anybody has any issues with any of this. And I'll bring handouts for the tutorial today in case anybody wants them. So that's all I have, everybody. We'll see you all next week or during the help session on Friday.